So let's look at this problem. This isn't really necessarily a section 3.4 problem. It's something that we've done before. So if I look at this, how do I know if it has a maximum or a minimum value? Okay. Since this is a positive x squared, we know we have a parabola that opens up. So that means it is a minimum. Okay. If I ask you for that value, what am I asking you to do? Right. This highest or lowest point is the vertex. So we know the x value of the vertex is opposite of b over 2a. So my b is negative 2, so that would be 2 over 2 times 3. So we get 1/3. Is that my highest or lowest point? No. That's the x where it occurs, so then we plug that in. So we get 1/3 minus 2/3 plus 1, it'd be a positive 2/3. So the actual minimum value is your y, so that would be the 2/3. You can. That would be fine. So if I ask for the actual highest or lowest, I'm asking for the y value of the vertex, because y is the variable that measures the height. Is that one okay? So let's look at this. Alright, find two consecutive integers whose product is 56. So there is one maybe like this on your homework, and I kind of stepped it out in ABC because I don't want you to just write down the two numbers. I want you to use algebra to find them, kind of using these things. So we just know we have two random numbers. So if x is my first number, if they are consecutive, what would the second number be? Okay, that's defining your variables, and that is something that I am going to require when you're solving word problems. There's different ways of doing it, and they have to know what your variable represents. So x and x plus 1. What if I said they were consecutive even integers?
X plus 2.
Okay. What if they were consecutive odd?
X plus 2.
Still x plus 2. All right. Then their product. What does product mean? So x times x plus 1 means equals 56. Alright, so then this is a problem that we should be able to solve. So if we distribute subtract over the 56. So then this does factor nicely. X squared breaks into x. What multiplies to negative 56 and adds to positive 1?
Positive 18 over 7.
So if we set those equal to 0, we get x to be a negative 8 and positive 7. All right, how do I want you to answer a word problem? With a sentence. Okay, so does it mean that my two consecutive integers are negative 8 and positive 7? No, those aren't consecutive. So if x is negative 8, then the other one is x plus 1, so negative 8 plus 1 is negative 7. Or if the first one is 7, the second one, 7 plus 1, would be 8. So the integers could be negative 8 and negative 7, or they could be positive 7 and positive 8. Is that okay? Once you guys do this assignment, so I've stepped it out in an ABC type question. So I told you that x is one of two positive numbers whose sum is 33. Part A. Represent the other number in terms of x. What do you think? Okay. So let's go with that for a second. So I don't want an x and a y, but if I did call my numbers y for x and y for a second, what do I know about those two things? They have a sum, which means what? So if I called them x and y, when you add them, it has to equal 33. So what would you do to get y by itself? So if they add up to 33 and one number is x, the other number has to be 33 minus x. If I say two numbers add up to 10 and the first one is 2, the second one is 8, 10 minus 2. Okay, so now I have both numbers in terms of x. Part B, find a function that represents the product of the numbers. What does product mean? Multiplication. So my numbers are x and 33 minus x. You could call this P for product if you wanted. If you want to go ahead and distribute, you can. So you have 33x minus x squared. So part B, I just asked for the function or your equation here for how we get our product. All right, then part C. I want to know the actual numbers. All right, and I want to know the maximum product. I should have probably asked, what's the maximum product first, and then what numbers are those? So what two numbers would give me a maximum here? So what do I need to do to find the maximum of this? Well, that would find out when it's 0. But if I want the maximum, so what are the numbers, let's say, that give the maximum product? How do you find? Vertex. Maximum is a vertex. So opposite of B over 2A. What's my B value? So opposite of B would be negative 33 over 2 times negative 1. Okay, then how do I find the second number? And what does that give you?
272.
So we need to answer our questions. I've asked for the numbers and I've asked for the product. The first number is 16.5. I know the second one from part A is 33 minus x, so 33 minus 16.5 is also 16.5. So both numbers are 16.5. The maximum product, so this was what I got when I plugged it into my product equation. So the product is 272.25. Okay, so we had 2 figured out. what equations to use or what expression to use for the numbers. But then when I ask for maximum or minimum, anytime I'm asking you to find that vertex. Any questions on that one? Look at this one. A piece of property shaped as a right triangle with the longer leg 10 meters shorter than twice the other. The hypotenuse is 20 meters longer than the longer leg. Find the length of the legs. That didn't really make a whole lot of sense, did it? So, yeah. So let's start out. We have a right triangle. Okay, the hypotenuse is the longest side or opposite the right angle. So the longer leg, the legs are these two sides here that touch the right angle. The longer one is 10 meters shorter than twice the other. So let's call one of these sides X. I don't know what it is. 10 meters shorter than. What does that mean? So we're going to subtract 10. Twice the other. So 2x minus 10. And that's the longer of the two legs. The hypotenuse is 20 more than, or 20 longer than, the longer leg. So here's my longer leg, 2x minus 10. If I want 20 longer than that, what would we have to do? So that side is 2x plus 10. All right.
How do you get to it?
Negative 10 plus 20. So I have everything in terms of one variable. But that's pretty much all I gave you, and I have to somehow figure out what these legs are. What do we know about right triangles?
A squared plus B squared plus C squared.
The Pythagorean theorem, a squared plus b squared equals c squared. This works in a right triangle. A and B are the two legs, C has to be the hypotenuse. So A, my first side, squared, plus B, the 2x minus 10, squared, equals C, 2x plus 10, squared. So I have x squared plus. How do you do 2x minus 10 squared?
4.
Means there's two of them. So you get 4x squared minus 20x, so minus 40x plus 100. Same thing here. If we FOIL, we get 4x squared plus 20x and plus 20x be 40x plus 100. And we could combine like terms, so that's a 5x squared.
We cancel.
What do we always set quadratics equal to? So if I subtract over this stuff, 5x squared minus 4x squared, that's just a 1x squared. Negative 40x minus 40x will be negative 80x. 100 minus 100 is 0, so I could drop that. What do I do now? GCF, we could take out an x. So set each one to 0, so x is 0 or 80. Alright, we need to make sure, are both of these options?
No.
No, we're talking about a piece of land. Can you have a piece of land with a side length of 0? No. So the 0 is not reasonable in this case. The question asked me the lengths of the legs, so these two sides here. So one side is x, which is just 80. The other side, 2x minus 10. So 2 times 80 minus 10, 150 meters.
Does it also want the
Hmm.
Does it also want the
It only asks for the legs on this one. Other questions there? All right, I want you to take a minute and see if you can set this one up.
Does it have to equal 120?
Yeah, okay, so we have a rectangle. Did you guys draw a rectangle?
Yes.
Okay, good. All right, we are going to use the barn as one side. So that means we're not actually putting fence on all 4 sides, so we only have to worry about 3 of them. Okay. We have 120 feet of fence. Let x represent the length of one of the parallel sides of fencing. So if this side is x, you know in a rectangle the opposite side is also x, right? Let's call this y for a minute. You know that 120 is how much fence you have, so what would you have to do with these? So my other side is 120 minus 2x. Now I want the area. How do you get area? So x times 120 minus 2x. Or if you want to multiply that out, 120x minus 2x squared.
Should we flip it around?
Yes.
So like 2x squared.
Negative 2x squared plus 120. Any of those 3 options are fine. So part B, how do I get the maximum?
Opposite.
So 30 is my x, so the other side, 120 minus 2x, is 120 minus 60, so 60. So that's the dimensions. We also need the area, so if we plug that into our area,
Or not. Did I put it back? So you do.
oh, not 60, 30. That should have been a 30 there. X was 30. So it should be 1,800. Is that what you guys got?
Yes.
So, the maximum area is 1,800. We were in feet, so square feet. The dimensions are 30 feet by 60 feet. Probably do one last example and then I'm done for today. Give you guys time to work if you haven't already done that handout. Any questions on this one? Alright, last one. We've done some kind of like this before with the vertical motion. So if a projectile is shot upward from the ground with an initial velocity of 73.5 meters per second, neglecting air resistance, its height in meters above the ground t seconds after projection is given by this equation. All right, all you really need there is this equation, and to know that s is height and t is time. So part A, what's the height after 2 seconds? What would we do?
Place T.
We're in meters. Part B, what is the maximum height? So we get 7.5. Is that my height? No, that is my time in this case. So to get the actual height, we have to plug that in. Okay. All right, last one. How long will it take to return to the ground? So what's that mean?
Plug in 0 for T. Or
S. That means if you're on the ground, the height is 0. How would you solve that?
pick out T.
Okay, you could take out your GCF, or at least the T. So if you set each one to 0, you don't want to divide by a variable because it could be 0. Although in this case it won't matter because we get a time of 0, but is that when it hits the ground? No, that's because you started on the ground. So we won't need that one here. So what do you get?
15. Couldn't you say it was 15 since it reached its crest at 7.5?
Mm-hmm.
No.
If you recognize that it's a parabola, so it's going to reach its maximum halfway up, and that happened after 7.5 seconds, it should take 7.5 seconds to come back. Now that wouldn't work if you had to start it on the ground when you threw it. You know, if you were standing on top of the desk and threw it up, that wouldn't work. But if you're starting on the ground, it would.
Well, I feel like you never really start on the ground. Like they don't know you.
That's true.
No, if you launch it from something. You're
Yeah.
Yeah, but if you're throwing it,
If you're actually throwing it, you
Yeah.
have some height involved.
what was it like?
All right. This was a projectile.
Be-
recognize the 7.5 as a problem, what we're going to show that.
You could just write down, like, even a sentence explaining, so since the maximum was this, I doubled it to get 15. Okay, there's